students. This is the second day of this series. In the previous lecture, I taught you motion in a straight line and motion in a plane. I gave you a brief understanding of the topics so that you can do the numericals on your own. Now in today's lecture, I will be discussing about units and measurements and I will be discussing about laws of motion. So these are the two chapters for today. We will try to cover the main basics, and today I will mainly focus on NCERT only because it is the NCERT level exam. So I'll be mainly focusing on the examples of NCERT and plus whatever content is written in NCERT, so that briefly we can cover all the topics in one go. So let's start the particular lectures. Today's topic is basically units and measurements and laws of motion. So let's start. So directly let me come to the NCERT part. So what does NCERT say and all these things? I think it will be visible to you. Let me zoom it also. It will be visible to you. So basically first is the introduction part. Introduction part does not have any main concept. The only main concept is they have written something which is called as fundamental or base units, and some things which is written as derived units, and one is system of units. So let me briefly explain to you what do you mean by all these things. The fundamental or the base units, if you will understand, fundamental quantities are those quantities which are basically what? Which are basically do not depend on the other quantities for their definition. Like length, mass, time, all these quantities are fundamental quantities. What are the derived quantities? The derived quantities will be the one which will be basically depending on the fundamental quantities for their definition. Okay? So all the quantities leaving the fundamental quantities are basically called as derived quantities. Okay? Briefly I am explaining, no need to write, just listen, just brief the concept so that you can do the numericals. After that, the concept is of system of units. When we are talking about system of units means what? System of units means a collection of all the units or a collection of all the fundamental quantities so that we can understand about different physical quantities. So this is basically the concept of system of units. Let us come to the next concept. See, a lot of system of units were developed, in which the most common or the most used system of units is basically the international system of units, or we can also call it as SI system. There were other system of units also, like if you see, there was a CGS system, there was a FPS system, there was an MKS system. In CGS system, it refers to centimeter, gram and second. That means the unit of length is centimeter, the unit of mass is gram, and the unit of time is second. In the case of FPS system, basically we talk it as foot, pound and second. And in MKS system, we take meter, kilogram and second as the units. So in all these three systems, basically three fundamental quantities were there: length, mass and time, and the units are also written in front of you. But in the case of SI system, when we will talk about SI system, basically SI system consists of 7 fundamental quantities. So what are the 7 fundamental quantities? The 7 fundamental quantities are, it is written here: length, mass, time, current, thermodynamic temperature, amount of substance and luminous intensity. So basically let me just quickly brief you about the different units of this. The unit of length will be meter, the unit of mass will be kg, unit of time will be second, unit of electric current will be ampere, unit of thermodynamic temperature will be Kelvin, and the unit of amount of substance will be mole, and the unit of luminous intensity will be candela. So these are the 7 fundamental quantities which you must know. There is no need to learn the definition of these fundamental quantities, that is not required. Only you need to know the units of length, mass and time, all these 7 fundamental quantities. One more thing, there are 2 supplementary quantities also. The supplementary quantities are the definition of plane angle. The unit of plane angle, the SI unit of plane angle is radian, and the definition of solid angle, the unit of solid angle is basically steradian. So basically 2 quantities more are there. One is plane angle, the unit is radian, and one is solid angle, the unit is steradian. So basically these quantities you must know. Let's move forward. After this, again, this is basically how to convert one system to another system, that is not required. After that, let us come to the most important concept, that is the concept of significant figures. So when we are talking about significant figures, what are significant figures actually? Significant figures tells us that basically if you are doing a measurement, suppose any physical quantity is there and you are doing the measurement of that physical quantity. So whatever physical quantity you will measure, you will get some certain digits. The collection of all the reliable digits and the last uncertain digit, basically that collection is called as significant digits or significant figures. There are some rules to find the significant figures. We'll discuss those rules. We'll strictly be confined to NCERT. Whatever is written in NCERT, we'll use only those rules. More than that, we'll not use any rule. So basically, in significant digits, what is the definition? The definition is that the reliable, see here, the definition is the reliable digits plus the first uncertain digit are known as significant digits or significant figures. Very important definition. What is the definition of significant digits or significant figures? The collection of all the reliable digits in a measurement plus the last uncertain digit which you are not sure of, that it can be this also or this also. Like you have done a measurement 234.5 centimeter. So that last digit is uncertain. It can be 0.5, it can be 0.6, it can be 0.7, it can be anything. So the collection of all the reliable digits, all the certain digits and the last uncertain digit, that will be called as what? Significant figure or significant digit. So I hope this is understood by you. So some examples are given, like let us suppose we can take this example. Suppose the length of an object is reported after measurement to be 287.5 centimeter. So the length is how much? 287.5. If the length is 287.5, then what will be the significant digits in this? It will be 2, 8, 7 and 5. So basically there will be 4 significant digits. Out of these, 2, 8 and 7 are the reliable digits. They are the certain digits. It is written here that digits 2, 8, 7 are certain, while the digit 5 is uncertain. The digit number 5 is uncertain and the digits 2, 8, 7 are basically certain. So all these collection will be called as the concept of significant digits. I hope this is clear to you. Let's move to the next concept. And now let us come to the most important logic, that basically what are the rules of significant figures. But before going to that, let me highlight one more important point. See here. Let me highlight one more important point. If you look properly here, then there is a statement which is written that a choice of change of different units does not change the number of significant digits or figures in a measurement. This is very important point. What they are actually saying is that if you have done a measurement in a particular unit, suppose you have done the measurement of length in centimeters, and now let us suppose you change the unit of length to meter or to kilometer or some other unit of length, then always remember the significant digits should never change. If you change the unit of any measurement, the significant digits should never change. That is what they have written, that a choice of change of different units does not change the number of significant digits or figures in a measurement. And one more thing, they have given an example also. The length 2.308 centimeter. Obviously, we know that it has 4 significant figures. I will tell you also the rules to count significant figures. You will understand carefully. Has 4 significant figures, but in different units, the same value can be written as 0.02308, 23.08 millimeter or 23080 micrometer. So if you change the unit from centimeter to meter or to millimeter or to micrometer, the unit is changing, but the number of significant figures should never change. So this is basically the most important logic what I am talking about in the case of significant figures. Chalo, let's move forward. And now let me tell you all the important rules regarding significant figures, whatever are given in NCERT. Very important, please understand carefully. What they are saying. The first rule is that all the non-zero digits are significant. Whatever non-zero digits you will get, they will be always significant. Second rule, all the zeros between two non-zero digits are significant, no matter where the decimal points is, if at all. What is they saying? They are saying basically that if there is a zero between two non-zero digits, like let us suppose, let me come to the note. Let us suppose I say that there is let us suppose 2304. So suppose you have done some measurement and the rule came out to be 2304. So how many significant figures will be there? The significant figures will be 4. Suppose there is another rule that says that it is 23.04. Then here also how many significant figures will be there? There will be 4 significant figures. So what does the rule say? What I told that the rule says, please understand, the rule says that all the zeros between two non-zero digits are significant no matter where the decimal point is. Even if there is a decimal point or there is no decimal point, the 0 in between two non-zero digits will always be significant. What is the third rule? If the number is less than 1, the zeros on the right of decimal point but to the left of the first non-zero digit are not significant. If there is a number or if there is a measurement which is lesser than 1, then the zeros on the right of the decimal point but to the left of the first non-zero digit are not significant. We can also say that the first zeros, the leading zeros, we can say they are never significant. Like example, 0.002308, the underlined zeros are not significant. This is the first non-zero digit. Before that, whatever zeros are coming, they will never be significant. Understood the logic? This 0 will be significant because it is between two non-zero digits according to the first rule. So basically, whatever zeros are coming before the first non-zero digit, even though decimal point is there or not there, they will never be significant. The next rule is the terminal or trailing zeros in a number without a decimal point are not significant. Any terminal zero or trailing zero means what? The zero which is behind the last non-zero digit. Whatever zero is behind the last non-zero digit, that will be not significant if there is no decimal place. Please understand. If there is no decimal place, without a decimal they are saying. Like let us suppose I take one example. Suppose I say that 2304000. So how many significant figures will be there? There will be 4 significant figures. These 2 zeros will never be considered as significant. I hope it is clear to you. One more example, they have said that 123 meter or 12300 or 123,000 millimeter, all these will have only 3 significant figures because these 2 zeros will not be significant. They are the trailing zeros and there is no decimal place coming in front of them. So basically these are the rules of trailing zeros in the case of without decimal. If decimal comes, then what will happen? The trailing zeros in a number with a decimal point are significant. If there is a trailing zero and there is a decimal point also, then always the trailing zeros will become significant. For example, 3.500. Now, if point would not have been there or decimal would not have been there, then I would have said that these zeros are insignificant. But since point has come, decimal has come, so these two will become significant. So how many significant figures are there? 4 significant figures. For this number 0.06900, this zero, the leading zeros are not significant. The leading zeros, whether decimal is there or not there, leading zeros will never be significant. The trailing zeros will become significant if decimal is there. The trailing zeros will not be significant if decimal is not there. So trailing zeros, these two zeros will become significant. So how many significant figures are there? Here also there are 4 significant figures. I hope this particular point is clear to you. Now let's come to the next point. So this thing I already told you, all these things, what are the different cases. And here one more point is written that for a number greater than 1 without any decimal, the trailing zeros are not significant. For a number greater than 1 without any decimal, the trailing zeros are not significant. I already told you, whatever number is more than 1, if there are trailing zeros and there is no decimal point, they will not be significant. But for a number with a decimal, the trailing zeros are significant. The main concept is, main crux is this, that if there is a decimal point, the trailing zeros will become significant. If there is no decimal point, the trailing zeros will not be significant. The leading zeros will never be significant, whether there is decimal or there is no decimal. So I hope these rules are clear. Achha, one more thing, one more rule is there. The multiplying or dividing factors which are neither rounded numbers nor numbers representing measured values are exact and have infinite number of significant digits. That means if there is a number which is basically exact number, it is not measured by any quantity or it is not measured by any instrument, those numbers will have infinite number of significant figures. Please remember, it is a very important point. So these were the basic rules of calculating the significant figures. And now let us look at the rules for arithmetic operations with significant figures. What does it mean? Suppose you are adding quantities or subtracting or multiplying or dividing, you are doing some arithmetic operations and you want to know that in the final result, what should be the significant figures in the final result. So there are 2 main rules, please understand carefully. There are 2 main rules which you have to understand. One is multiplication or division rule. I am only telling you the crux of NCERT. Whatever is the important points of NCERT, only those things I am telling so that it is very easy for you to basically revise this particular topic and do the numericals. So in the first rule, what they are saying? They are saying that in the multiplication or division, the final result should retain as many significant figures as are there in the original number with the least significant figures. What they are saying, that if you are multiplying or dividing two quantities, and let us suppose in one quantity you are having 3 significant figure and in the other quantity you are having 4 significant figures, then in the final result how many significant figures should be there? 3 should be there. That means you have to retain the minimum number of significant figures when you are doing multiplication or division. They have also given one example. Example is that suppose you want to find the density of any body and you are dividing these two terms. This is having 4 significant figures. This is having 3 significant figures. So the final result has to come as 3 significant figures only. You cannot take 4 significant figures into your calculation. So this was the first rule. The second rule which is saying is that in addition or subtraction, the final result should retain as many decimal places as are there in the number with the least decimal places. So in the case of multiplication or division, you have to calculate significant figures and the final answer will be reported in the least significant figures. In the case of addition or subtraction, you have to report the final answer in the least decimal places. Suppose the first number is having 3 decimal places, second number is having 2 decimal places. So when you will add or subtract them, then the final answer should contain only 2 decimal places. They have given one example also. Like let us suppose I want to do the sum of these numbers, 436.32 gram, 227.2 gram and 0.301 gram. So first number is containing 2 decimal places, here it is 1 decimal place and this is 3 decimal place. So I have to get the answer in terms of only 1 decimal place, and what is that 1 decimal place? The final answer according to me is actually, the final answer will come out to be this 663.821, but this is not the exact answer because we have to calculate only in terms of 1 decimal place. So if you look properly, the final answer will be written here and the final answer will be basically 663.8 gram only. So I hope this is clear to you. So again, let me repeat it. Very simple. 2 rules are there. For multiplication, division, what you have to do? For multiplication and division, you have to only think about the least significant figures. And for addition or subtraction, you have to think in terms of least decimal places. I hope this point is clear to you. Now, one more thing is very important, that is rounding of the uncertain digits. Because obviously I told you that in division and multiplication, least significant figures should be there. Suppose more significant figures come, then you have to eliminate some digits. So for eliminating the digits also, there are some principles which are used, which are called as rounding off principles. So in the case of rounding off principles, what we have to do is, please understand carefully, in rounding off principles, what are the rules of convention? Understand, the preceding digit is raised by 1 if the insignificant digit to be dropped, the underlined digit in this case, is more than 5. So whatever digit you have to drop, if that particular digit is more than 5, then the preceding digit will be raised by 1. If that digit is less than 5, then the preceding digit will not be changed. So is raised by 1 if the significant digit to be dropped, the underlined digit is in this case is more than 5, and is left unchanged if the letter is less than 5. So if the letter is less than 5, then it will be remaining unchanged. If the letter is more than 5, then the preceding digit will be basically raised by 1. But let us suppose if the digit which is being dropped is basically 5. They have said that if the number is 2.745 and you have to drop the digit, the insignificant digit which you have to drop is basically 5. Now what you will do? When the digit to be dropped is equal to 5, then you have to check the previous number. The previous number you have to check. If that previous number will be even, then basically what will happen is, if in that particular case there is no change, you cannot drop that particular digit, or you don't raise any number by 1. But if the previous digit is odd, then raise that particular number by 1. It is written here also that if the preceding digit is even, the insignificant digit is simply dropped, and if it is odd, the preceding digit is raised by 1. Again, I am explaining what is it meaning. It is very important. In your 3rd May exam which happened, which was cancelled, this was having a very ambiguous concept. In that particular case, basically the answer which NTA gave was according to these rules only. The actual answer, whatever it is, 7.7 some people were giving, that can be the actual answer, but we will follow only NCERT. For NCERT purposes, we will look at these rules. According to these rules, we will get 7.6 as the answer. So what I am saying is the preceding digit is even. If the preceding digit is even, then there is no need to change that digit, just drop that particular 5. But if the preceding digit is odd, then raise that particular odd digit by 1 and then drop that particular 5. So this is what they are saying. I hope these rules are very much clear to you, and now these were some examples of that. So like let us take one example given in NCERT. एक example ले लेते हैं. Suppose I take example 1.1. I hope it is visible to you. They have said that each side of a cube is measured to be 7.203 meter. What are the total surface area and the volume of the cube at appropriate significant figures? So this is what they are asking. Side of the cube is given to you. How many significant figures are there in this side? 4 significant figures. They are asking the total surface area and the volume of the cube to appropriate significant figures. Now when you will calculate the surface area of the cube, we know that the surface area of the cube is what? 6a square. So basically it will be 6 multiplied by 7.203 whole square. You will get this number. But actually this will not be the answer, because in the final answer, how many digits should be there? In the final answer, the least significant figure should be there. The least significant figures are basically 4. So 4 significant figures have to be retained. That means your answer, your 9 digit has to be dropped. The digit 9 has to be dropped. Now the first digit which has to be dropped is basically more than 5. So the preceding digit will be raised by 1. So the answer will be 311.3 meters square. Second case, volume of the cube they want. Again, it will come out to be this much big number, but this is not the answer. We want only 4 significant figures. So we want to retain only till 7. So we will look at this digit. This digit is less than 5. So the preceding digit will not be changed and you will get this as the final answer. So here we have used 2 rules. One is the rule of multiplication and division and one is rounding off principle. Let's look at the next question. Again, this question can be done by you. 5.74 gram. 5.74 gram of a substance occupies 1.2 centimeter cube. They are asking you to express its density by keeping the significant figures in view. So density is basically what? Mass upon volume. Let's do the question. So when you will do mass upon volume, you already know that mass is 5.74 gram. Volume is given as 1.2. You will divide them. But here please remember, these are how many digits? These are basically 3 significant digits. These are how many digits? These are basically 2 significant digits. So your final answer should contain only 2 significant digits. So the final answer will come out to be 4.8 gram per centimeter cube. I hope these rules are clear to you regarding the arithmetic operations and the rules to count the significant figures. Okay. So basically these are the things. Now they have written something about errors and all those things. Achha, one more thing I want to highlight, that whenever you are doing intermediate calculation, then the intermediate results in a multi-step computation should always be calculated to one more significant figure in every measurement than the number of digits in the least precise measurement. What they are saying is that whenever you are calculating a multi-step calculation, wherever multiple steps are there, then in the intermediate calculations, you always have to retain one digit extra than the least precise digit. So that particular rule has to be taken care into account, and in the final result you have to use all those calculations which were already given to you, which I already explained. Okay, so this is very important concept. Okay, so these were basically the concepts of significant figures and the concept of precision. Now let me come to the concept of dimensions of physical quantities. So what are the dimensions? Basically, whenever you want to represent any derived quantity, suppose you want to represent a derived quantity. So to represent that particular derived quantity, what we have to do is we have to basically convert that derived quantity in terms of fundamental quantities. Now, when we convert any derived quantity in terms of fundamental quantities, there will be some powers of those derived quantities or of those fundamental quantities with which this derived quantity is made. Those powers of fundamental quantities are called as dimensions. So the example is written here, that what is dimensions? The dimensions of a physical quantity are the powers or the exponents. Powers are sometimes called as exponents also. to which the base quantities are raised to represent that quantity. So base quantities or fundamental quantities, the powers of those fundamental quantities are basically called as derived quantities. Like let us suppose in the example, suppose I have I have volume. So the volume will be equals to what? Volume is basically length cube. So it will be L cube. M is what? Mass. L is what? Length. T is what? Time. Generally we write it in terms of these quantities only because there is no dimension of mass and time. So we'll write M0, L3 and T0. Velocity is basically length upon time. So we'll write M0 LT minus 1. In the same way, we can represent the dimension of all the quantities if we know the formula. Suppose we know the formula of force. Force is mass into acceleration. Mass can be written in M. Acceleration is length upon time square. So LT minus 2. So we'll get MLT minus 2. So this is how we can write the dimensions of different physical quantities. Now let us do the dimensional analysis of some quantities and its applications. So please understand one thing. The first dimensional application is checking the consistency of dimensions or checking the dimensional consistency of equations. So basically what does it mean? Suppose you are adding two quantities or you are subtracting two quantities. Always remember only those quantities can be added or subtracted which are having same dimensions. You can add length with length, you can add mass with mass, you can add volume with volume, you cannot add length with time. 2 meter plus 2 seconds is not having any significance. So basically, if you want to check the dimensional consistency of equations, you can use the concept of principle of homogeneity. What does it mean? Principle of homogeneity of dimensions, which says that whenever you are adding two quantities or subtracting two quantities, then you are getting a third quantity, then the LHS and the RHS, all the quantities should have same dimensions. But it is not necessary that two quantities which are being multiplied or divided, they should have also same dimensions. For multiplication division, there is no problem. You can add, you can multiply or divide any two quantities which are basically having different dimensions. But for the case of addition or subtraction, you have to remember that always they have to add only when they are having same dimensions. One more important point is given here. Let me discuss. Let me take one example also. Like let us suppose x is equal to x naught plus v naught t plus half at square is given to you. You want to check the dimensional consistency whether it is correct or not. So x refers to the distance traveled. So what will be the dimension of x? It will be equals to L. X naught also refers to the initial position of the particle. So the dimension of x naught is also L. Now v naught t, v naught represents velocity and t represents time. So LT minus 1 into t will give you L. So this is also correct. Half at square, is half any significance? No. The numbers do not have any dimension, so please ignore the value of numbers. There is no reason to take numbers into account. So numbers do not have any dimensions, only this particular point will have dimensions. So at square if you will do, a we already know it is LT minus 2, it is acceleration, t square will be t2, so it will be L, the dimension will be L. So if you see properly, all these terms which are being added are all having the same dimensions, and the LHS also and the RHS also all having the same dimensions. That is why we will say that this particular quantity is dimensionally correct. Dimensionally correct it is. Will it be physically correct also? I cannot tell. Why? Because I don't know whether this number can be half, it can be 2 also, it can be 3 also, it can be anything also. By dimensions, I will not be able to calculate what is this number. So if I say to you a statement that all the dimensional quantities, all the dimensionally consistent equations are physically correct also, no, it's not possible. It is not true. They can be true, they cannot be true. But all the physically correct, all the dimensionally correct equations are physically correct also, it may be. But all the physically correct equations have to be dimensionally correct. Always remember, if there is an equation which you have proved that it is dimensionally correct, then it is not necessary that it will be actually correct also. But if a quantity is physically correct, it has to be dimensionally correct also. So I think this rule will also be written to you. Let me read. Here it is a very important thing which is written, that if an equation fails this consistency test, it is proved wrong, but if it passes, it is not proved right. Please understand one thing. If this consistency test is passed, it may or may not be true. But if it is failed, consistency test is failed, then definitely it is false. So if the equation fails this consistency test, it is proved wrong, but if it passes, it is proved, it is not proved right. Thus a dimensionally correct equation need not be actually an exact correct equation, but a dimensionally wrong, incorrect or inconsistent equation must be wrong. I hope this particular concept is clear to you. So one more example is given to you. You have to check the dimensional consistency. I think you can easily do it. Half mv square is one equation and one is mgh. So please check the dimensional consistency. I think you will be able to do it. A very simple question. Try this question now. You will be able to do it. Next, again one question is given that the SI unit of energy is itna, speed is itna, and this they are asking you the dimensionally consistency of these equations. Please check whether the dimensionally consistent or not. Again, I think this particular question can be done based on whatever we have discussed. Let me drink some water, then we will continue. Okay. So this is one of the application. Let me look at the next application, deducing the relation among the physical quantities. So this I will explain you with the help of an example only. So this please read it. Consider a simple pendulum having a bob attached to a string that oscillates under the action of a force of gravity. Suppose that the period of oscillation of the simple pendulum depends on its length, mass of the bob and acceleration due to gravity. Derive the expression for its time period using the method of dimensions. So what you have to do, you have to basically derive this particular experiment using the method of dimensions. The time period is depending on what? The time period is depending on the value of length, the value of acceleration due to gravity g, and the value of mass. How to do this particular question? Please understand, very easy question, and this type of application can also be asked in your exams. So whenever, let me do it here, please understand, time period is proportional to what they have said. Time period is proportional to length ki power x, g ki power y, m ki power z. Length ki power x, g ki power y, m ki power z. So I want to know what is x, y and z. Very simple to calculate. Please understand. You will remove the proportionality. You will get some constant. K, L to the power x, g to the power y and m to the power z. Now k is a dimensionless number, we will assume. Here we will write the dimension of time, that is m naught, L naught t. Here we will write L to the power x. Here we will write LT minus 2 to the power y. And here we will write m to the power z. So what we are getting? We are getting m to the power z, L to the power x plus y and t to the power minus 2y. This is m0, L0, t. Now because all these two equations are correct, so their powers will also be matching. So I can write z is equal to 0, z is equal to 0, x plus y is also equal to 0 and minus 2y is equal to 1. So I'll get y is equal to minus 1 by 2, and if I put it here, I'll get x is equal to 1 by 2. X is equal to 1 by 2 I'll get. So what will be my final answer? My final answer will be time period is equal to k, L to the power 1 by 2, g to the power minus 1 by 2 and m to the power z is 0, so m to the power 0. That means it is coming out to be k under root of L by g. Will I be able to calculate the value of k from dimensional analysis? No, I will not be able to calculate, because that is the limitation of dimensional analysis. This k, we are assuming that it is dimensionless, but even if it is having dimension, we will not be able to calculate. But this formula is basically correct. So this is how basically you can calculate the dimensional formula with the help of, or the formula of different quantities with the help of dimensional analysis. This is what they have written. If you see the solution, same solution they have written, k root L by g. K value you will not be able to calculate. K value can only be calculated by experiments or by physical methods. So you know that the time period of simple pendulum is 2 pi root L by g, so k value will be 2 pi. So I hope this particular thing is clear to you. So with this, our first chapter, that is units and dimensions, basic concepts, whatever was written in NCERT, I have told you all the things, whatever were written in NCERT. And now let us go to the next concept, and the next concept is what? The next concept is basically laws of motion. So now let me come to the next logic, that is laws of motion. Please understand carefully. Okay? Let me take this backward. Okay, so now let me come to the laws of motion. I hope this particular thing will be clear to you. So in laws of motion, what we have to do, please understand. In laws of motion, basically we have to know what is the meaning of the different Newton's laws of motion, the main three laws, the concept of inertia, the main three laws of motion, which is the first law, second law and third law, and basically some examples, some questions based on those laws. Very simple chapter. We also have to understand here something about circular motion. In circular motion, how the different laws of motion can be applied, what is the meaning of centripetal force, what is the meaning of centrifugal force, all these things we have to understand. This is a numerical based topic basically, but the relevant theory I will tackle, and we'll do some examples based on NCERT. Okay, so mainly we will concentrate on NCERT because we have limited time and we have to do a lot of things in this. I'll also tell you something about conservation of momentum here, and what is the condition when you have to apply conservation of momentum, what are the common forces in mechanics we have to discuss, some questions basically involved in circular motion we have to do. So let's start here. Let's start this particular topic, and let me somewhat zoom it. I hope this is visible to you. So introduction, there is no need basically. Just I want to know one thing, that basically I want to tell you what is the meaning of force. So what is force? Force is nothing but a push or a pull. Basically, if you want to accelerate a body, if you want to produce an acceleration in a body, then you have to apply some push or pull to the body. That push or pull which is responsible for changing the motion of a body, or obviously it tries to change the motion of the body, that particular case is called as a force. Now that force can do many things. It can change the speed of the body, it can change the direction of motion, it can change the shape or size also of the body. So basically this particular concept will be called as force. Now there are basically in nature four fundamental forces. There are four fundamental forces which are present in nature. One is a gravitational force, the force between the earth and the moon and all the celestial objects. If any object is being dropped, then the force with which earth pulls the objects towards itself, that is also called as gravitational force. Then there is electromagnetic force, very strong force. Electromagnetic force is basically the force between charged particles. Then there is nuclear forces. There is a weak nuclear force and there is a strong nuclear force. These nuclear forces are basically very short range forces. They are mainly inside the nucleus. The gravitational force and the electromagnetic force are very long range forces. Okay? The most strongest force are the strong nuclear force. After that there is electromagnetic force. Then there is weak nuclear force, and the weakest force is gravitational force. So basically these are some terms which I told, that like this: external agencies, example gravitational and magnetic forces, can exert force on a body even from a distance. Acha, one more thing, one more classification of forces is there. One is a contact force and one is a non-contact force. If there is contact between the bodies, then the force acting between them is basically called as contact force. Like normal reaction, you might have studied normal reaction, tension in the string, then friction, all these are basically contact forces. Spring force is also a contact force. But there are also some forces which do not require any contact. Like gravitational force actually do not require any kind of contact. Suppose if I throw a pen from here, then there will be no string which will be coming from earth and it will be pulling here. If I throw it, automatically it will go down. So basically that is a non-contact force which earth is applying. That is also called as field force. When we will discuss gravitation in detail in the upcoming chapters, then you will be able to understand what is basically a non-contact force. And one more force is there, that is the very important force, that is electromagnetic force. That is also a non-contact force. Electromagnetic forces are comprised of two things. One is electric forces and one are magnetic forces. So these are all non-contact forces. Okay. So basically now they are asking you that is an external force required to keep a body in uniform motion? By a very important question they have asked, that is an external force required to keep a body in uniform motion? If a body is doing uniform motion, is there any external force which is required? If you will ask me, then I will say that net force, if there is a body which is doing uniform motion, that means its velocity is not changing, that means it is not under any acceleration, then the net force acting on the body will be zero. But external forces can still exist on the body. Like let us suppose if I take a block and if I apply 10 Newton from here and 10 Newton from here, then the body will be at rest. Or it can move with uniform motion, but still there are external forces which are acting on the body. So basically the first concept regarding this was given by Aristotle, and Aristotle basically gave a fallacy. What was that fallacy? The fallacy was that an external force is required to keep a body in motion. Actually, this is not the case. If a body is moving uniformly, then the body can move without any net force. The net force acting on the body should be zero. That is why Aristotle's this particular law is given by Aristotle's fallacy. Fallacy means he wrongly gave this particular concept. He thought that this is happening, but actually this is not the case. After that, Newton came and a lot of scientists came and they proved this particular thing wrong. And what they told is, let me tell, please understand, the law of inertia they gave. So the first thing which they gave was law of inertia. So what is law of inertia and what is inertia? Inertia is the ability of a body to be at rest. If a body wants to be at rest, it can be inertia of rest, it can be inertia of motion, it can be inertia of direction. The ability of the body to stay at rest is basically called as inertia of rest. If you want to change that particular ability, if you want the body to move, then you have to apply an external force. Otherwise, it will remain at rest only. So the ability of the body to stay at its original particular position, whether if it is moving with uniform motion, then it will always move with uniform motion only. If it is at rest, then it will always be at rest. Until and unless somebody applies any external force on that body to change its particular state of motion. So that was basically the concept of law of inertia, and that law of inertia is also called as Newton's first law. It states that a body which is at rest or in uniform motion will continue its state of motion until and unless you apply a net external force on the body. So what is this law of inertia saying? Please understand carefully. The law of inertia is saying that a body which will be at rest will remain at rest, and the body which is motion will continue its motion until and unless you apply an external force on the body. So this is basically the law. Let me read it. The first law of motion: every body continues to be in its state of rest or of uniform motion in a straight line unless compelled by some external force to act otherwise. Very important law, and this gave you the definition of the force. That what is this force doing? This force can change the state of inertia, either inertia of rest or inertia of motion or inertia of direction, or indirectly we can say it can change the state of motion of the body. If this particular net external force is not acting, then the body will always stay in its state of rest or of uniform motion. So this was the main concept. Let's move forward. After that, there were some ideas on motion on ancient Indian science. There is no need to read this paragraph. It is not at all important. Let us go to the next. Okay. So this was basically the Newton's first law of motion. I already told you what is Newton's first law. Let me explain it again. That if the net external force on a body is zero, its acceleration is zero. Acceleration can be non-zero only if there is a net external force on the body. Simple terms, they are saying that if the net external force is zero, the body will not change its state. There will be a uniform motion, so there will be no acceleration. If you have to create acceleration in the body, then you have to apply a net external force acting on the body. Chalo, let's move forward. And now let us come to the next concept, that is, chalo, let's take this example. What they are saying? They are saying an astronaut accidentally gets separated out of his small spaceship accelerating in interstellar space at a constant rate of 100 meter per second square. So there was a spaceship in space and there was an astronaut in that. It accidentally gets separated out of this spaceship. The acceleration of the spaceship was 100 meter per second square. What is the acceleration of the astronaut? The instant after he is outside the spaceship, assume that there are no nearby stars to exert gravitational force on him. So basically, if you are separated from this spaceship, you will come in interstellar space. Now, if you are in interstellar space, obviously there are no forces acting on you. Neither the spaceship is applying force. Spaceship can apply force because of its mass, but they are saying that you have to ignore the gravitational forces acting on him. So basically what will happen? Please understand. If you see here properly, what they have written? They have written, since there are no nearby stars to exert gravitational force on him, and the small spaceship exerts negligible gravitational force attraction on him, the net force acting on the body, the net force acting on the astronaut once he is out of the spaceship is zero. By the first law of motion, the acceleration of the astronaut will be zero. What they are saying, that once that particular astronaut is out of the spaceship, now it is in interstellar space. Now there are no stars which are applying gravity on him, they have said in the question. And one more thing, they are saying that the interstellar, the spaceship is not that much dominant that it is applying a huge gravitational force on the astronaut. So that will also be negligible. That is why the net force acting on that particular astronaut will be zero, and once that particular force is zero, then the acceleration will also be zero. So according to Newton's first law, it will be moving in a uniform circular motion. So I hope this particular concept is clear to you. Chalo, let's move forward. The next law is Newton's second law. Newton's second law states what? Newton's second law basically gave the picture of or the calculation of net external force. Newton's second law said that if there is a net external force acting on the body, then there is a quantity which is called as linear momentum of the body. That momentum quantity will change. So if there is a net external force acting on the body, then basically the linear momentum of the body will change, and the net external force will be equals to the rate of change of linear momentum of the body. So what does it state? That the first law refers to the simple case when the net external force on a body is zero. The second law of motion refers to the general situation when there is a net external force acting on the body. It relates the net external force to the acceleration of the body. How it related to the acceleration of the body? Let me explain it here. Please understand. Let me explain it here. Net external force will be equals to what? Net external force will be equals to rate of change of linear momentum of the body, dp vector by dt. Now we know that linear momentum is basically mass into velocity. This we already know. So basically what it will be, d by dt of mass into velocity. Now generally we take such cases in which mass of the body is treated as constant. If the mass of the body is treated as constant, what we will write? We will write net external force is equal to mass will come outside, so we will get dv vector by dt. तो कितना हो जाएगा? dv vector by dt will be what? dv vector by dt will be equals to acceleration, rate of change of velocity. So we will get net external force as mass into acceleration. So very important statement, that if there is a net external force on the body, then obviously there will be a acceleration on the body. And how to relate that acceleration of the body with the net external force? It is net force is equal to mass into acceleration. Okay, this is a very simple concept. Now let me read this particular concept. First they have given the definition of momentum. So momentum of the body is what? Momentum of the body is basically defined as to be the product of its mass m and velocity v, and it is denoted by p vector. P vector is equal to mv, and the rate of change of this momentum will be given by net external force. So this they have written in the form of examples also. I'm not reading the examples, please read it on your own. These are very simple examples. And let me go to the next concept. Okay, so these are the different examples. I already derived this particular result for you. We have finally derived this particular result, that F net will be equals to mass into acceleration of the body. Okay? And this is basically the definition of the second law of motion. This is basically the definition of the second law of motion, that the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. Okay? So what will be the force? The force will be equal to rate of change of momentum, and in whatever direction the momentum change is happening, in that direction only basically the force will be acting. One more thing, because force is a vector quantity and momentum is also a vector quantity, so in different directions also you can apply the force. So you can apply the force in x direction, it will become dpx by dt or m into ax. Fy will be equals to dpy by dt or may, and fz will be equals to dpz by dt, that is m into az. So mass into acceleration in the z direction. So these are basically the terms related to this. Let me take one example based on this so that you understand carefully. Let's look at this particular case. So one question is there here. Yes, let's look at this question. What they are saying, there is a bullet of mass 0.04 kg, the mass is given, moving with a speed of 90 meter per second, enters a heavy wooden block and is stopped after a distance of 60 centimeter. So initial speed of the body is given 90 meter per second, mass of the body is given, and the final velocity is 0 because it is stopped, and the distance after which it will stop, that is given to you. They are asking what is the average resistive force exerted by the block on the bullet. So this is what they are asking. So how we will do it? Very simple. See, in this particular case, first we can find the acceleration of the body. First let us find the acceleration of the body. So how to find this acceleration? Very simple. We know that v square is equal to u square plus 2as. We can apply this equation, v square is equal to u square plus 2as. Now see, the final velocity is 0. You already know. So acceleration can be written as, acceleration will be minus of u square divided by 2 into s. U is already known to you. Initial velocity, the acceleration is also you want to calculate, and the distance is also known to you. You will solve it, you will get the acceleration value. Once you get the acceleration value, now the retarding force will be what? We know that F is equal to ma, mass is given to you, acceleration you already calculated, you will solve it, you will get 270 Newton as the resistive force. So very basic example it was, but it will make it clear what is basically the concept of this. Achha, one more thing which I want to tell, in Newton's second law, whenever you discuss Newton's second law, basically in that F is equal to ma when you are applying, then if there is a system of bodies involved, more than one body is involved. So in the system of bodies, basically the interaction, the internal forces which one body is applying on the other, that will not be coming into picture. Only the net external force will be coming into picture. So this is what they have written in this particular statement, that any internal forces in the system are not be included in the net external force. Whenever we are applying F is equal to ma, in the net external force, the internal forces should not be included. One more particular example is there. Let us take that example also. They have said that the motion of a particle is described, mass m is described by y is equal to ut plus half gt square. So this is the displacement of the particle in the y direction. They are asking the force acting on the particle. Very simple. From this y we will differentiate 2 times to get the velocity and acceleration. So velocity will be what? Dy by dt. So when you will do dy by dt, what you will get? You will get u plus gt. And one more time if you will differentiate, you will get dv by dt. dv by dt will be equals to g. So the acceleration of the particle is coming out to be how much? It is coming out to be equal to g. And now once you have got the acceleration, we know that F is equal to ma. So you can get the value of ma, that is m into g. So this is also clear to us. Let's go forward. Next, one more topic is there which is called as impulse. Basically what is impulse? Let me tell you. Impulse is what? Impulse. Sometimes it is denoted by J vector. So impulse is nothing but the total change in momentum of a body. Because of the application of force, if there is a change in momentum of the body, then basically the total change in momentum will be called as impulse. So J vector will be equals to m into v final vector minus v initial vector, or I can also write it as m into delta v vector, or I can write it as delta p vector. This is basically the concept of impulse. Obviously it is a vector quantity. And one more thing, because I know that net external force is equal to dp vector by dt. So basically what will be the total change in momentum? Total change in momentum will be f vector into dt integration from 0 to t. This will be the total change in momentum. So I can also write impulse as integration f vector into dt from 0 to t. If your force will be constant, in that case the impulse will be given by f vector multiplied by t. Impulse will be given by f vector multiplied by t. So impulse can be written as force into time when your force is constant, but if the force is not constant, you have to apply integration. If there are large amount of forces acting for a very short interval of time, then the impulse, whatever you will calculate, the change in momentum will be basically called as impulse. But it can be applied in two cases. Either large forces are acting for a short interval of time, or small forces are acting for a large interval of time. In both the cases, you will get some change in momentum. Okay? So this is basically called as impulse. And what will be the unit of impulse? The unit of impulse will be kg meter per second, which is equal to the unit of momentum. So I hope this particular point is clear to you. So this is what they would have written, that basically impulse is what? It is force change in momentum, or it is basically equal to what? It is basically equal to force multiplied by time duration. Force into time duration or change in momentum, both can be applied in the case of impulse. Okay, let's move forward. Let me take one example also, very simple example. A batsman hits back a ball straight in the direction of the bowler without changing its initial speed of 12 meter per second. So there was a ball which was coming to a batsman with speed 12 meter per second. It hit the bat and then again it went back here. So there was a initial speed of 12 meter per second. Finally also it will be 12 only. And now if the mass of the ball is 0.15 kg, then determine the impulse imparted to the ball. Assume linear motion of the ball. So it is a very simple concept. Find the change in momentum. How to find the change in momentum? It will be mass multiplied by the final momentum will be 0.15 into 12 minus initial momentum will be minus 0.15 into 12. So the total momentum change will be 3.6 Newton second, and this will be basically the impulse, and it will be in the direction from the batsman to the bowler. So this is how you calculate the value of impulse, a very simple concept. Okay, let's look at the Newton's third law of motion. I am directly giving you the statement of this. This is already, you know it, that what is Newton's third law of motion in simple terms? To every action there is always an equal and opposite reaction. If there is an actional force, then obviously there will be a reaction force. But you have to remember one thing, that the action reaction forces should be of the same nature. If one is gravitational force, the other also has to be a gravitational force. The action reaction forces, basically the action reaction forces should be instantaneous. The action reaction forces should be of the same nature. The action reaction forces should always be applied on different bodies. They cannot be applied on the same body, and they should be equal and opposite in nature. So these are some terms based on the concept of action and reaction. So let's move forward. And here also let me write one statement, that forces always occur in pairs. Force on a body A by B is equal and opposite to the force on the body B by A. This I already told you, that it will always be occurring in pair, it will be always acting in different bodies, it will be simultaneous, it will be instantaneous, it will be basically of same nature, and it will be equal and opposite in nature. One more thing, there is no cause-effect relation implied in the third law. The force on A by B and the force on B by A act at the same instant. This I already told you, that this will not happen that you applied a force, after some time the reaction will come. No. At the same instant the reaction will come. You applied a force, at the same instant the other body will also apply a force on you. So this is basically the concept of Newton's third law. And based on this concept only, the law of conservation of momentum comes. But before that, let me give you one example. The example is, two identical billiard balls strike a rigid ball with the same speed but at different angles and get reflected without any change in the speed. What is the direction of the force on the ball due to each ball? The ratio of the magnitudes of the impulses imparted to the balls by the ball. So basically, they are actually asking you the direction of the force on the ball, and they are asking the ratio of the magnitudes of impulses imparted to the balls by the ball. So what will happen actually? In the first case, what they are saying is that in the first case, the ball is coming like this and it is going like this. So here what will be the change in momentum? In this case, the change in momentum will be 2m into u. The final momentum will be mu, the initial momentum is minus mu, change will be 2mu. In this case, you have to resolve the forces. So if you will resolve it, here what you will get? U cos 30. Here what you will get? U sin 30. Here what you will get? U cos 30. And here what you will get? U sin 30. If you see properly, there is no change in the momentum in the y direction. In the y direction, u sin 30 are both in the same direction. The only change is in the x direction. Here, initially it was u, finally it is u. Here it is initially u cos 30, finally also u cos 30. So the change will be what? Change will be 2u cos 30. So for this particular case, change in momentum will be 2m into u cos 30. And this will be the impulse, and if you want, you can calculate the ratio of those impulses. So this is what they have written. There will be no change in the initial and the final momentum in the y direction, but there will be a change in the x direction. So that is the answer coming 2mu cos 30, and the y component of impulse will be 0. I hope this particular example is also clear to you. From here only conservation of momentum comes. Conservation of momentum, let me briefly give you the concept where it will be applied. Whenever you have a system of two or more than two bodies and they are doing there is some event going on. It can be explosion of a bomb, it can be collision between the two bodies, it can be anything. In that particular case, what actually happens is that when one body applies a force on the other body and the other body also applies the force on one body, and you consider the system of these two bodies, then what will happen is the net external force acting on the system will be 0. Wherever in any situation, in any event, the net external force acting on the system is 0, then that particular system is called as that particular system is called as conservation of momentum. So what I am trying to say is that if in a system net external force acting on the body is 0, net external force acting on the body is 0, on the system of the bodies is 0, then the momentum of the system will be conserved. Initial momentum before the event and final momentum after the event will be equal. So this is basically the statement of conservation of momentum. So these are some examples. Let me give you the brief understanding also that the total momentum of an isolated system of interacting particles is conserved. Isolated system means the net force acting on the system is 0. Okay? So net force should be 0. So basically based on this we can give the examples. And then there are some different types of forces. Equilibrium we can do, and then there are some common forces in mechanics. This we already know, all these things we know. So based on this you can do some questions based on the concept of Newton's laws of motion. So different forces can be of different types. Tension in the string is one of the forces, then friction is one of the forces. Let me give you some examples of these tension and friction. Friction can be of two types. One can be static friction and one can be the kinetic friction. Static friction will be applied when static friction is basically opposing the change in motion, the tendency of the change in motion. The motion is not actually happening, but it is trying to happen. So whatever force opposes the change in motion, the tendency of the change in motion, that will be called as static friction. There is a maximum limit to that static friction, that is called as limiting friction. The limiting friction will be given by what? The limiting friction will be given by FL is equal to FL will be equals to mu S multiplied by normal reaction. And what will be kinetic friction? Kinetic friction will be given by mu K multiplied by normal reaction. Always remember, kinetic friction has to be lesser than or equal to limiting friction. So static friction is self-adjusting in nature. The maximum value of static friction can be limiting. Limiting friction is equal to mu S into N. Kinetic friction is basically equal to mu K into N, and this comes into picture when there is actual relative motion going on between the bodies. Static friction will happen when there is no relative motion between the bodies. There is a tendency of relative motion. Then static friction will act. So I hope this concept is also clear to you. Based on this, the different concepts of friction are also there. So I hope these concepts and these points are clear to you. You can do these examples now. These concepts will be clear to you. Okay. So with this we will complete our laws of motion particular concept also. Basic concept I have told you, different laws I have told, some forces and mechanics I have told, and now you can do the questions based on these particular laws. So in the next class we'll meet and I'll be discussing the concept of work energy power, and I'll be discussing collisions also in that, and some concepts of circular motion also I'll be discussing. Thank you. Thank you very much.